So this video is going to be short and sweet, I promise you. We are going to do the graph of tangent x. So we've already done the graph of sine, we've already done the graph of cosine, we've done some work with those graphs. So now, logically speaking, after sine and cosine, we are going to do tangent. Okay, and we need to remember two things in order to graph tangent. The first thing that we need to remember is that when I did my graphs of sine and cosine, I used my unit circle. So we are also going to use the unit circle to help us graph y equals tangent x. So I'm going to go ahead and graph my unit circle. Doesn't have to be perfect. Okay, and I'm going to go ahead and fill in like those 4 key points that we know on the unit circle. So I know that this is the point 1, 0, 0, 1, negative 1, 0, and 0, negative 1. Okay, so I needed that, and then I also needed to know, or I also need to know, or need to remember, that tangent is defined to be sine x over cosine x. Okay, so those are the two things that I'm going to need to use. Now, I'm just going to go ahead and throw up a graph. Trying to figure out the best way to size this. So, here's my y-axis. Here's my x-axis. Make that bigger. Hold on. It's been a while since I made you guys a video. Okay, and remember when we graphed sine and cosine, we wanted to pick x values, or we wanted to pick a domain that made sense. And for trig functions, we're inputting angles, so it made sense to have our x-axis be angles, and we always did it in radians. Now notice I included the negative x-axis, so I'm actually going to go not from 0 to 2 pi, but from negative 2 pi to 2 pi, just so you guys get a good image of this. And I'm going to go ahead and, label my axes right now. And, I mean, I'm sure you guys have already kind of figured out a system, but when I do this, I kind of like to put my 2 pi at the very end, and then I go by half. So I find the middle of this, and I know that'll be 1 pi. Then I find the middle of each of those pieces, which is going to be pi over 2 and 3 pi over 2. And then, depending on the problem, if you need like pi over 4 for 45 degrees, you could just go ahead and throw those in the middle here if you need them. Okay, and then the same thing's going to happen on the negative. So here's my negative 2 pi. The middle is going to be negative pi. Then I've got negative pi over 2, negative 3 pi over 2, and then I can get those pi over 4s if necessary. Okay, and we can go ahead and do 1 and 2 and 3, doesn't matter. Okay, so there we go. And when we did sine and cosine, we first started off with the biggies: 0, pi over 2, pi, 3 pi over 2, and 2 pi. Because those are what I know from the unit circle, right? Because this is 0, here's pi over 2, here's pi, and here's 3 pi over 2. So if I look at 0 degrees, well, I don't use degrees because this is in radians. So at 0, I look right here, I know that my cosine is 1 and my sine is 0. So the tangent of 0, remembering that tangent is sine over cosine, that is going to be 0 over 1, which is just 0. So here's this point. Okay, and now let's go to pi over 2. So when I'm at pi over 2, the tangent of pi over 2, okay, now we need to be careful. Tangent of pi over 2 is sine over cosine. The sine at pi over 2, my y value is 1. My cosine is 0. Okay, 1 divided by 0 is not 0. 1 divided by 0 is undefined. So if something is undefined, that means it doesn't exist. So the graph at tangent is not going to exist at pi over 2. We are going to put an asymptote in there because it is undefined. Okay, so you might want to jot that down. We're putting in an asymptote at pi over 2 because tangent is undefined at pi over 2. And to illustrate an asymptote, we're just going to put, I'll do it in a different color, we're just going to put a dotted line at pi over 2. So I know that I cannot happen at pi over 2. Okay? We'll come back to that later. Now, let's go ahead and look at pi. Let me extend my page a little bit. Oops. Alright, now when I do my tangent of pi, that's the sine over the cosine of pi. What is up with my board today? Okay, when I do the tangent of pi, the sine at pi is 0, the cosine of pi is -1, so I get 0. So at pi, I'm back at 0. When I look at pi, 3 pi over 2, I'm down here, the sine is going to be -1, the cosine is 0. That's another undefined value, okay, because 1 over 0 you can't divide by 0. So we're going to have another asymptote. This one's going to be at 3 pi over 2. Okay, and then back at 2 pi, well 2 pi is the same as 0, so I'm back here at 0. Whoops, wrong button. Back here at 0. Now, the same thing is going to happen on the negative side, right? Because going, if I went negative pi over 2, that's right here. Negative pi over 2 is the same thing as going positive 3 pi over 2. And that was undefined. So I'm going to have an asymptote here at negative pi over 2. And then I'm going to have another asymptote at negative 3 pi over 2. And I'm going to go ahead and put in these zeros. I'm going to have a 0 at negative pi, and I'm going to have a 0 at negative 2 pi. Okay, and this is actually a lot of information. I know it doesn't look like we've got a lot going on right now, but we do. Because these asymptotes are huge, all right, and also knowing that these zeros are huge. Now let's take a minute and just focus on the unit circle picture, because obviously there's got to be something going on between this pi over 2 and 3 pi over 2, right? There's got to be something going on in this area besides just blank space. So let's look at my whoops, that wasn't supposed to happen. There we go. Let's look at my unit circle. Because remember, tangent is sine over cosine, y's over x's. So if I look, let's take a minute and look at this piece between pi over 2 and 3 pi over 2. So that is in between here and here on my graph. Okay, first off, let's look just from pi to 3 pi over 2. Let's just look at this piece right in here. If I look at this, my sines, my y values, are getting bigger and bigger because I'm going from 0 to 1, right? Well, in this case, -1, but like the amount of y is bigger. My distance is growing. So from pi to 3 pi over 2, my y values are getting bigger because here it's 0 and here it's 1, so it's getting bigger. But as my y's are getting bigger, all right, as I'm moving further away on the y-axis, I'm moving closer in on the x-axis. All right, the point right here and the point right here, the y-coordinate is going to be bigger, but the x-coordinate is going to be smaller. So as I move from pi to 3 pi over 2, my y's are getting bigger, my x's are getting smaller. Well, if you have something really big, something that's getting bigger, divided by something that's getting really small, that's getting really big really fast. Okay, think about it. If you have 2 cakes and you need to divide them between 2 people, okay, but then suddenly you have 2 cakes and you have to divide it by 1 person, or you have 2 cakes and you only have to give it to, you know, half a person or like a kid or something like that, the amount of cake that you have is getting bigger and bigger and bigger because you're giving it to less people. So that means that between pi and 3 pi over 2, y divided by x is getting super, super big. So tangent is getting super, super big. So my graph is going to shoot up super, super big, up to infinity. All right, it's not actually going to get there because at 3 pi over 2 I have this asymptote. So I can get really, really close, but I can't actually touch 3 pi over 2, but I'm still going to get really, really big. Okay, if we look at this going between pi over 2 and pi, so now I'm looking at quadrant 2, all right, as I go between pi over 2 and pi, like this point here and this point here, my y values are getting smaller. I'm moving lower down on the y-axis, but my x's are getting bigger. I'm getting further away on the x-axis. So now when I look at y divided by x, my y's are getting small. Oops, put my eraser down. My y's are getting super small as I move between pi over 2 and pi. All right, because my y's are shrinking down to 0 because my y coordinate over here is 0. But my x's are getting bigger because my x's up here at pi over 2, my x is 0, but then my distance is growing to 1. So my y's are getting smaller, my x's are getting bigger. When you have something small divided by something really big, okay, like if you have one small cupcake and you have to divide that amongst the whole school, you are going to get something super, super tiny. It's getting really, 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 really small. So that means that down here, between pi over 2 and pi, this is going to shoot down to negative infinity. All right, you can't actually get to negative infinity, and we can't actually get to anything at pi over 2 because that's an asymptote. But as I get closer to pi over 2, I'm getting super, super small. Just as I got closer to 3 pi over 2, I got super, super big. Okay? And just like we could kind of copy and paste everything like we did with our zeros and our asymptotes, this is going to happen in every single one of these graphs. So like here at 0, this is going to shoot up to positive infinity, and this is going to shoot down to negative infinity. Same thing's going to happen in this piece. I'm going to shoot up to positive infinity. I'm going to shoot down to negative infinity. All right. From 2 pi, I could keep going with my graph, but I know here it has to go down. If I kept going, it would go up. And at negative 2 pi, this has to go up, and if I kept going, it would go down. So this is the graph of y equals tangent x. You need to know that this is what it looks like. The big ends are that you need to know where the asymptotes are, which if you do this quick little work, you know, these quick calculations using the unit circle should be pretty obvious. Okay, and let's see how I'm doing on time. Oh, not bad. Okay, I feel like there was something else that I wanted to say. Just like, you know, we looked at what tangent was doing in between pi over 2 and 3 pi over 2. I have no idea what just happened. We could do the same thing for all of these intervals, but you should, you know, after we did this little piece, you should realize that the same thing is going to happen in all those other little pieces. Okay, now, just like sine and cosine, we do consider tangent a curve. We do consider it a wave. So, like in this blue chunk that I highlighted right here, this is considered one period or one wave of tangent x. And if you look, the distance for this to go one full cycle, to go from negative infinity to infinity, is the distance from pi over 2 to 3 pi. So the period for tangent is pi, all right, because this distance on the x-axis for it to go through one cycle is pi. Same thing here. To go from negative pi over 2 to pi over 2, the distance is pi. Okay, so know that the period is pi, know that this is the graph of tangent, and know where these asymptotes are. And we'll do some more practice with it later.